Solving algebraic equations involving trigonometric ratios. Welcome, everyone. Today we are moving into a new topic, solving algebraic equations involving trigonometric ratios. Now, if you look back at our previous lessons, we focused on finding a single, specific angle when we were given a single trigonometric ratio. You've already mastered how to work with one unknown. However, in this new subsection, we are going to advance to more complex problems. Instead of just one unknown, we will be looking for the values of two different angles, which we will refer to as angle A and angle B. In these types of problems, you won't be given the angles directly. Instead, the problem will provide you with trigonometric ratios for the sum of the angles, written as a plus b, or the difference of the angles, written as a minus b. To tackle these, we aren't just using trigonometry. We are going to bridge two different areas of math. We will combine our knowledge of trigonometric tables with the algebraic method of solving simultaneous linear equations. It's a great way to see how different mathematical concepts work together to solve a single problem. Conceptual approach. The primary goal here is to transform trigonometric statements into simple algebraic equations. Essentially, we want to strip away the sine, cosine, or tangent functions so that we are left with just plain numbers and variables. To do this effectively, the process follows three logical steps. First, we must identify the angle. Instead of looking at the whole expression, we use the given trigonometric ratio and our knowledge of standard values to find the value of the combined angle. For example, if you are given the sine of a minus b, your first task is to determine exactly what that entire expression, a minus b, equals in degrees. Second, we need to formulate equations. Usually, you will be working with two different ratios. By finding the values for both, you will create two separate linear equations. Finally, we solve the system. Once you have those two equations, the trigonometry part is actually over. You are now back in the realm of algebra, where you can use standard methods, such as the elimination method or the substitution method, to find the individual values of A and the individual values of B. Now that we've introduced the topic, let's look at our conceptual approach. Before we dive into the calculations, it is vital to understand the underlying strategy. In the next slide, we will walk through a concrete example to see this exact process in action. Step-by-step example. Now that we understand the conceptual approach of turning trigonometric statements into algebraic equations, let's put this theory into practice with a concrete example. Here is our problem. We need to find the specific values for two unknown angles, A and B. To do this, we are given two pieces of information. First, the sine of the quantity A minus B is equal to 1/2. Second, the cosine of the quantity A plus B is also equal to 1/2. To keep our calculations straightforward and focused, we will assume that both the sum of the angles, a plus b, and the difference, a minus b, fall within the range of 0 to 90 degrees. This ensures we are working within the first quadrant, where all trigonometric ratios are positive. Let's move on to the next slide to see how we break this down step by step. Step 1. Solve for the first combined angle, AB $. Now that we have understood the conceptual approach, let's dive into the first actual step of our example. Looking at the first piece of information provided in our problem, we are given that the sine of a minus b equals 1/2. Now, to move from trigonometry into algebra, we need to find the angle that corresponds to this ratio. If you refer back to your table of trigonometric ratios for specific angles, you will recall that the sine of 30 degrees is equal to 1/2. Because these two values are identical, we can strip away the sine function and simply equate the angles themselves. This gives us our very first linear equation, which we will label as equation 1, a minus b equals 30 degrees. Step 2. Solve for the second combined angle, A plus B $. Now that we have successfully found our first equation in the previous step, let's move on to step 2, where we solve for the second combined angle. Looking at our problem statement, we are given that the cosine of a plus b equals 1/2. Now, just like we did with the sine ratio in the last slide, we need to refer back to our standard trigonometric tables. We can see that the cosine of 60 degrees is exactly 1/2. Because these two expressions are equal, we can strip away the cosine function and simply equate the angles themselves. This gives us our second linear equation, a plus b equals 60 degrees, which we will label as equation 2. We now have both pieces of the puzzle needed to proceed to the next step. Step 3. Set up the system of linear equations. Now that we have successfully used our trigonometric tables to find the values for both the sine and cosine expressions in the previous steps, look at what we have achieved here. We have transitioned from trigonometry into pure algebra. We now have a system of two linear equations, each containing two unknown variables, a and b specifically. Our first equation is a minus b equals 30 degrees, and our second equation is a plus b equals 60 degrees. From here, we are no longer dealing with trigonometric ratios, but simply with a standard simultaneous equation problem that we can solve using basic algebraic methods. Step 4. Solve for $1 using the elimination method. Now that we have successfully set up our system of two linear equations from the previous steps, we move into step 4, where we will solve for the first variable, a, using the elimination method. To begin, we are going to add equation 1 and equation 2 together. When we add the left side of the first equation, a minus b, to the left side of the second equation, a plus b, the negative b and the positive b will cancel each other out, leaving us with just two a's. On the right side of the equals sign, we add 30 degrees to 60 degrees, which gives us a total of 90 degrees. This simplifies our equation down to 2, a equals 90 degrees. To isolate a, we simply divide 90 degrees by 2, which results in a equals 45 degrees. We have now found our first angle, and in the next slide, we will use this value to find the value of b. Step 5. Solve for $b by substituting the value of a. Now that we have successfully found the value of angle A, we need to find the value of angle B. To do this, we will use the method of substitution. We'll take the value we just calculated, where a equals 45 degrees, and substitute it into our second equation, which was a plus b equals 60 degrees. When we plug 45 degrees in for a, our equation becomes 45 degrees plus b equals 60 degrees. To isolate b, we simply subtract 45 degrees from both sides of the equation, which leaves us with b equals 60 degrees minus 45 degrees. Performing that subtraction, we find that b equals 15 degrees. This completes our algebraic steps, and in the next slide, we will present our final results. Final answer. And there we have it. After using the elimination method to find the value of a, and then substituting that back into our second equation to find b, we have reached our final answer. The two angles we were looking for are a equals 45 degrees and b equals 15 degrees. This completes the calculation for our example problem. Common mistakes to avoid. Now, before we wrap up today's lesson, I want to pause and discuss some common pitfalls. Even if you understand the method, it is very easy to make small errors that lead to the wrong final answer. First, watch out for confusing your sine and cosine values. It is a very common mistake to see 1/2 and accidentally think of sine 30 degrees instead of cosine 60 degrees, or to confuse sine 30 degrees, which is 1/2, with cosine 30 degrees, which is the square root of 3/2. To avoid this, I highly recommend that you always double-check your trigonometric summary table before you write down your linear equations. Second, pay close attention to your sign handling when solving the algebraic part of the problem. When you are working with the system of equations we just solved, a simple mistake with a plus or minus sign can change everything. For example, if you have the equation a minus b equals 30 degrees and you substitute 45 degrees for a, you must calculate b as 45 degrees minus b equals 30 degrees, which correctly gives you 15 degrees. If you aren't careful with the subtraction, you might mistakenly end up with 75 degrees. Finally, a very important rule: do not try to skip the combined angle step. A common error is attempting to solve for A or B directly from the trigonometric ratio itself. Remember, you cannot jump straight to algebra. You must first use the ratio to find the value of the entire expression inside the parentheses, the argument, before you can move on to solving the linear equations. Keep these tips in mind, and you will find these problems much more manageable. Key takeaways. First, I want you to think of these problems as a bridge between two different worlds, trigonometry and algebra. As we saw throughout our step-by-step example, you cannot jump straight to the individual angles. You must follow a specific two-step transition. You start with the given trigonometric ratio, use your tables to find the value of the combined angle, and only then can you move on to finding the individual angles. Second, notice that once you have successfully navigated the trigonometric part, the complexity actually decreases. The problem transforms into a standard grade 9 algebraic task, solving a system of simultaneous linear equations, just like the ones you have practiced before. Finally, always remember the power of verification. One of the best things about math is that you can check your own work. You can always verify your final answers by plugging your calculated values for A and B back into the original trigonometric ratios to see if they hold true. For instance, if we take our result and test it, we can see that sine of 45 degrees minus 15 degrees equals sine of 30 degrees, which indeed equals 1/2. This simple check can give you great confidence in your final answer before you even hand in your paper. To wrap up our lesson today, let's review the key takeaways to ensure you have a solid grasp of this topic.